In this video, I will discuss the center of gravity. Now, what is center of gravity? It is the point through which the entire weight of the body acts, and it is denoted by the point G. The figure shows that there is a body and which weight is W, and the weight is acting at point G. So G is the center of gravity of this body. Suppose 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 this is the book, and you know that the weight of this book will act at this point. Weight of the entire book will act through this point. So, so this point will be the CG of this book. CG helps to keep the body in equilibrium position. Some important points to remember regarding CG. The body is always having one CG. Any body do not have more than one CG. The CG of the body is independent of the position of the body. That is, CG of a body does not change if its position is changed. Suppose I'm removing this book from here and keep it here. The CG will remain the same. The, the point will not change. CG is nothing but a point actually. It is an imaginary point. So the CG of this book will not change. The CG of a body depends upon the shape of the body. Now if you change the shape of this body, now let us say the shape, I have changed the shape of this body like this. Then the CG will not act at this point. It will act some other point. Let's say it will act here. So the CG of a body depends upon the shape of the body also. The CG of a body is an imaginary point which may or may not lie within the body. It is not essential that the CG will lie within the body. It may lie outside the body. Now another term is centroid or center of area. Centroid is the point through which the entire area of the lamina is supposed to be concentrated. The term centroid is used for a body which does not have mass, that is a lamina. A thin sheet of paper is a thin sheet of paper is known as lamina because it doesn't have any mass. So this is the lamina. So if the CG is used for body which has mass. So centroid is used for a body which doesn't have any mass, and the term CG is used for a body which has mass. So if you assume that the entire area, let us say the area is A, the entire area of this lamina is concentrated, let us say at this point. It is an imaginary point, is concentrated at this point, then the CG of this lamina will act at this point. So this will be the CG of this lamina. Lamina which doesn't have any mass. Now the difference between CG and centroid. Number one, the CG is the point through which the entire weight of the body acts, and centroid is the point, and centroid is the point at which the entire area of the lamina is supposed to be concentrated. Second point is CG is used for bodies which have mass, and centroid is used for bodies which doesn't have mass. Now methods of determining CG. There are methods of finding out the CGs. Number one is geometrical method. Number two is graphical method, and number three is method of moments. So this is the first method, geometrical method. CG by geometrical method. How you find out the CG by geometrical method is used to find out the to find out the center of gravity of regular figures like rectangle, triangle, circles. Uh, to find out the CG of these regular figures, we use the geometrical method. Although geometrical method and graphical methods are not in our course, we are concerned with the method of moments. Now, how to find out the what are the find out CG of some plane figures and solids. How we find out the CG of some plane figures and solids. Although the derivation of this is not in your course, so I will not discuss the derivation. Only you have to remember the, the, the position of CG of the following regular figures to solve any numericals based on center of gravity. Now, CG of a rectangle. In case of a rectangle, the CG lies at the point where the two diagonals intersect each other or at point G as shown in the figure. So this is the ABCD is a rectangle. Uh, Now if you join the diagonals AC and BD, they intersect at point G. So G is the point at which the CG lies, which is at a distance. We know that the diagonals intersect each other at the midpoint. So it is L upon 2 and B upon 2 from AB and AD respectively. So the distance, now the CG is because it is a point, so we have to find out, if you want to find out the CG, that means you have to find out the coordinates of the point, that is x bar and y bar. X bar is the x coordinate and y bar is the y coordinate of the CG. So if you want to find out the CG, that means you have to find out x bar and y bar of that body. Now x bar is the distance of CG from point A along the along the horizontal line. Horizontal line is AB. So if you are measuring CG from AB of a rectangle of length L and breadth B, then x bar will be L upon 2 and y bar will be B upon 2. Now in case of a triangle, CG lies at a point where the three medians of the triangle meets. The figure shows that these are the three medians, this and these are the three medians which intersect at this point. So this is the CG which is denoted by G. Now this point is at a distance h upon 3 from the base BC and is at a distance b upon 2 from point B. So x bar is b upon 2 and y bar is h upon 3. What is x bar? X bar is the distance of CG of this rectangle of point G from horizontal axis, that is BC, and y bar is the distance of G from uh, x bar. X bar is the distance of CG from vertical axis, that is from this line, from this line. So this is from this to this. This is x bar, that is b upon 2, and y bar is the distance of CG from horizontal axis, that is h upon 3, from this to this. Now, in case of a right angle triangle, the the CG will be x bar will be b upon 3, x bar that is measured from the vertical line. So this is b upon 3, and y bar which is measured from the horizontal line, that is h upon 3. So x bar is b upon 3 and y bar is h upon 3. Now in case of a circle, CG lies at the center. So x bar and y bar is a d upon 2, which is shown in the figure. Now in case of a semicircle, uh, the center of gravity is shown with point G. So x bar is a d upon 2 and y bar is 4r upon 3 pi. Now in case of a quadrant, x bar is 4r upon 3 pi and y bar is again 4 upon 3 pi as shown in the figure. Now in case of a hemisphere, x bar is d upon 2 and y bar is 3r upon 8. Case of a cylinder, x bar is d upon 2 and y bar is h upon 2. In case of a right circular cone, x bar is d upon 2 and y bar is h upon 4. So this is all about this is uh, the theoretical portion of the CG. In the next video, I will discuss how to find out the uh, I will discuss the method of moments to find out the center of gravity of any given body.